Okay, so let's look at the inverse function, something that we are familiar with, especially from the grade 12s and so on. Now, a function is said to have an inverse. Let's call this function this. It's said to have an inverse, and this inverse is this, as x maps y, right? If it is a one-to-one what function. I think previously we looked at a one-to-one function. So let's look at the examples. So find the inverse for the following functions. I'll keep on writing them. So the first step is that you replace f of x with y. So replace f of x with y. Then solve for x. Alright, then solve for what? Solve for x. That's the next step. So we have y equal to 2x plus 4. So solving for x, we group y and 4. So that we have this, right? Then that, then that. So our x is equal to y minus 4 over 2. And the last step is that where is y? Replace that with x. So where there is y, replace that with x. So replace x with this and y with x. So this x will replace with this, and this y will replace with x, and that gives the inverse. Number 2, f of x, 2x to the power 3 plus 1. What do? Solve for x. Sorry, substitute this with y, so that we have, now we solve for x, of course. So solving for x, we just give us y minus 1 equal to 2x to the power 3 over 2 over 2. So x to the power 3 equal to y minus 1 over 2. Now the moment we reach this stage, what do? We introduce the cube root to both sides. So introducing the cube root to both sides, we mean this and that. So that and that can cancel. So that x is equal to 3 root of y minus 1 over 2. When you reach this stage, you replace x with f and y with x. This is the inverse. Another one is f of x equal to 3x over 5. So where there is f of x, we introduce y to give us this. Then we cross multiply. This will give us 5y equal to 3x. We solve for x. We solve for x over that. So then we place that with that. Then we move to another component, even and odd function. Okay, so let's start with even. So a function f of x is said to be even if f of a is equal to f of negative a. For every a, like that, minus, should give you a t 0. Now, even functions, in an even function is always symmetric about the y what? The y axis. Okay, so any function in the form of this, where n is even or an integer, but it's an integer which is also what? Even, then that function qualifies to be an even what? Function. So an even function is symmetric about the y-axis, like that. All right, it's always symmetric about the what? The y-axis. On the other hand, odd function, a function f of x is said to be odd if f of a is equal to negative f of a. Okay, such that f of a, negative there, plus f of a, okay, is equal to what? 0. Now it is symmetric about the what? The origin. All right, about the what? Origin. For example, a function of x to the power 3, it is symmetric about the what? The origin. That is the point, the origin, like that. Of course, that is y, that is x. Now we can just look at the example of determining functions even or odd. So it says show whether the functions below are even or odd. So we need to show whether each of the following here, each of the functions here is odd or even. So what do? We know that, let's try if the first function is even. If f of x equal to x to the power 4 is even, then we expect this to hold. Right? So let's go. So f of a, we put there, what do we get? We just get a to the power 4 equal to, what is x, we put negative a to the power 4. What do we get? We get a equal to, this is this to multiply by 1, multiply by itself 4 times, we just get a to the power 4. And this shows you that f of a is equal to f of negative a. Hence, from here we can conclude that f of x equal to x to the power 4 is even. Simple. B says x to the power 5. F of x equal to x to the power 5. Let's show if it's even. What do we so we first show if it's even. This should always hold if it's even. So here we get a to the power 5, and here we get negative a to the power 5. So a to the power 5 is equal to negative a to the power 5. You get negative a times negative a 5 times, you get negative a. You get negative a like that. Okay, something like this. Now you know that I can factorize here, right? So a to the power 5, I can take out the negative and I'll remain with that, and this corresponds. Now, is this equal to this? No. Therefore, we can say it is not even. It is not what? Even. But which one obeys this rule? It's the odd function. The one we said for odd function, this must hold. and we can clearly see a to the power 5, and f of a is there, and the negative is outside. So this function is what? Is odd. So just those two rules and you are gone. You are good to go.